and we're gonna roll right into our next speaker, and that is Raymond Baltar from the Sonoma Biochar Initiative. He's been working with some different industries out in California, and he's gonna talk about some different methods for biochar production. So without further ado, hello, welcome, Raymond.
Great. Well, thanks a lot for inviting me, Andy. I really appreciate it. Can you hear me okay?
Yeah, we can hear you, and you're able to share your screen. And I'll just mention one more time, I think I actually forgot to mention this. If you have questions, put them into the Q&A box, and then we'll get them in order there. The chat is like more for, hey, thank you, clapping emoji. You can share your credit card and the number in the chat if you would like to share that with us, but for that sort of thing. Put your questions in the Q&A box, and we'll get to that at the end. So thank you, Raymond.
Great. Well, thank you. So I have quite a few slides. I'm going to try to kind of barrel through them, pun intended. So I'm going to talk about a variety of things, but primarily sort of an overview of some simple techniques you can use to produce biochar out of your own vines or other local materials. So I'm going to just kind of jump right into this. Hang on a sec. Okay, so just quickly, I've been working with the Sonoma Ecology Center on various biochar-related projects since about 2009. The Sonoma Ecology Center is in the beautiful Sonoma wine-growing region, Sonoma Valley, right over the hill from Napa Valley. And the Ecology Center has been working for over 30 years on various environmental restoration research projects, and it's really been great to work with them. So I'm just going to quickly go over, I'm going to talk about what biochar is, some do-it-yourself methods of making it, some benefits of biochar, how to use it, and some larger scale methods as well. So what is biochar? It's simply a specialized form of charcoal that's suitable for use in agriculture. It's useful in many, many other areas as well, but you know, the primary interest here is in ag, and we think that it's the highest and best use for biochar ultimately. So biochar in soil functions much like a coral reef in the ocean. It acts as a natural attractant and an incubator for life. It creates an infrastructure for communities of microorganisms, and it has many, many other benefits as well. This is obviously a close-up picture. There are millions of tiny little areas where moisture, nutrients can be held and stored for the plants down at the root level, and also obviously for microorganisms. One really critical factor is that not all biochars are equal. There are many, many different attributes depending on the type of material that you use. There are people that are making char out of manures and grasses and all kinds of stuff. We tend to think that sort of the heavier duty woody matter, of which grapevines would apply, make some of the best chars. But you can make biochar about just about any kind of biomass that's available. So out here in the West, this is a very typical scene during burn season. Obviously, you've heard, we've had some burn problems out here, many of them. And so, but in the fall, or usually actually midwinter, it starts looking like this in the valley here. And so, years ago, we kind of looked at this and said, hey, what can we do to figure out how to reduce the amount of smoke? And oh, by the way, we can also produce this great material biochar. So let's do it. And as you probably know, or maybe don't, there's many, many nasty chemical compounds in wood smoke. And so reducing that locally will please your neighbors and yourselves, and will also be able to make biochar. So this is probably a typical pile. Out here, people pile it up. It's green material. They don't age it properly. And this is what ends up happening. So this is, again, very simple pile techniques I'll show you in a minute on how to reduce the smoke and then also save a lot of the carbon in that plant material. So first, you can, for ages, biochar has been made in pits, just like this. You dig out a hole, you throw your material in, you let it catch on fire, you keep adding material until it goes up to the top, then you cover it and let it smolder. It cuts off the oxygen, and so it doesn't allow the coals to turn to ash. And so a lot of the carbon then is saved in this very stable form we call biochar. So this is a really simple method. Anybody can do it. And it's doesn't hardly cost anything at all. So the methods that we've been pioneering are called top-lit conservation burns. We've taught probably 35 to 40 different vineyard managers, forestry people, CAL FIRE, any landowners. You can use vines, you can use on the left-hand side here, those are obviously some fuels reduction materials. But again, as you'll see, the material has been lit from the top. And I don't know if you can see my little cursor here, but the reason that this method works, when you start the fire from the bottom, like we all have, we've all been taught that since, Boy Scouts or whatever, up here, it's not combusting as much. And so the smoke, it creates smoke, and that smoke just goes up and out. When you light the fire from the top, the smoke happens down here, and that smoke gets pulled up through the flame front. So it gets incinerated much more cleanly, and there's virtually no smoke except at the very beginning of the process if you do it correctly. So this is another technique that we're now pioneering. We got a grant from the North Coast Resource Partnership to purchase 5 of these kilns. And then we had 2 grant partners, the Redwood Forest Foundation and the Potter Valley Indian Tribe, that's been using these very successfully on their forest slash materials. You can also use vines. We recently did a program for the Napa RCD. So this is sort of a more efficient way than the conservation burn. It's a sort of a double-sided sheet metal thing. It's very simple to put together. They're inexpensive. These particular ones cost about $1,000. And they're very, very efficient at making biochar and also have significant smoke reduction as well. So there are starting to be many other smaller farm scale units. Some of them are mobile, other ones are more stationary, but every year there seem to be more people who are jumping into this, and there is no one single method. And I'm not sure what you have available out there, but there is a company in, I think it's Massachusetts, New England Biochar, that makes a unit I'll show you a little bit later. So what are exactly the savings? We say that you can save up to 50% of the carbon material in that plant material, keep it in a very stable form that will last hundreds of years in the soil without degrading or without most of it degrading. But what actually are the emission savings? So a couple of years ago, we started to partner with a couple of air districts that have been very, very interested in allowing these to go forward as a best practice, because they've seen it themselves, and they see how beneficial it is and how little smoke is produced. So we've been working on an emissions proposal with CAPCOA, which is the parent group for all the air districts in our state, and the Missoula Fire Science Lab, which is a Forest Service lab, to get funding so that we can actually do measurements. So we're almost done with that proposal, and we hope it'll go forward during the next burn season, and we can get actual data which will, show exactly what emissions are being saved with this kind of technique. We're also going to do it with the kilns because those are becoming very, very popular out here. So what are the benefits of biochar other than saving, saving smoke and saving carbon. Well, it's been shown in many different studies to improve water retention, and it reduces soil compaction. It can improve plant production. It's not across the board, but there's a lot of research still going on in this area. But it definitely has, we actually did a study out here. I have a link to it later in the program, of an Oasis Vineyard field trial we had in the Monterey area, where we significantly increased the plant growth and the fruit growth without impacting the quality of the grapes, and on the same amount of water as our control. So I don't think you have the same water issues out there in Michigan that we have, but I'm not sure, but that's a big deal out here. It can improve soil porosity. It has this amazing interaction with mycorrhizal fungi, and increases that. And here's a picture that was done by Josiah Hunt of Pacific Biochar, which he had thrown some biochar into a manure pile, and lo and behold, look what the fungi attached itself to. There is some kind of amazing interaction that goes on there. So it definitely kind of helps to feed the good fungi growth. It also decreases nutrient leaching. You saw those holes earlier that allow nutrients to be sort of held in state and utilized by plant roots over time. It improves cation exchange capacity. And one kind of an important note, it's this sequestering of greenhouse gases. For every pound of biochar that's produced and put into soil, it removes about 2.5 pounds of CO2 from the carbon cycle. And this is for a very long time. This is in the century time frames, which is obviously a very important quality of biochar at this point. So other environmental benefits, it's been shown to reduce nitrous oxide by a huge amount. This was a study done by partially by Johannes Raymond of Cornell, who's one of the sort of godfathers of the movement. And as you know, nitrous oxide, a lot of it comes from nitrogen-based chemical fertilizers, which hopefully many of you are not utilizing. But anyway, it can, that's another benefit. It also reduces phosphorus and nitrogen leaching into groundwater, and it can be used and is being used to revitalize brownfield sites. And biochar works especially well in your worst soils, your most degraded soils, and in sandy soils. You'll get benefits in other soils, but you'll get increased benefits in the worst soils that you have. So biochar is an investment in carbon drawdown. It's been cited as a significant natural climate solution by the Intergovernmental Panel on Climate Change, proceedings of the National Academy of Sciences, the Nature Conservancy, Lawrence Livermore Lab. And as you can see here on the chart, this is from the IPCC report, that biochar, in the lower left, along with afforestation, reforestation, and soil carbon sequestration, are all among the least expensive techniques for carbon storage. And some of the others, like direct air capture and others, are sort of theoretical, and whether or not we can scale them up economically or not. But using biochar in soil is one of the least expensive and potentially very impactful. There was another study by Johannes Raymond done that showed that if we utilized all of the waste, quote unquote, waste materials or surplus biomass worldwide, that we could sequester between 10 and 12% of all of the anthropogenic carbon that we're putting up every year into the atmosphere. So it's not going to solve global warming, but it's one of the slices of the pie, one of the things that we can do. And as growers, you can all be a significant player in this. There are also a lot of movement towards carbon credits right now and establishing protocols for those. So in the not too distant future, you may be able to actually get $100 a ton or even more for putting biochar into your soil. That's not an enormous amount, but every little bit helps. So biochar has also been used, is mostly used in Europe with cattle farming because they have discovered that adding very small amounts, 1 to 3% in cattle feed, can reduce the enteric methane by up to 25%. And so and it's a very efficient method of inoculating the char, because when it comes out the other end, it's perfectly inoculated and ready to use if it can be gathered up. So it's also been used in making chickens healthier, and for the same reason, when it comes out the other end, it helps reduce the odors that are related to chicken farming. So there's an RCD out here that has been experimenting with using biochar and wood chips as a filtration medium, sort of a large-scale filter, and they've had some very good luck in capturing some of the nutrients coming off the local strawberry fields that are related there. So, and they've been having a lot of problems with algae blooms that once the excess nutrients get into the waterways, and so this is yet another use for biochar. And in case all that isn't enough, you can look up Hans-Peter Schmidt's cascading use of biochar, and he goes over a whole bunch of different ways that biochar is either being used now or is being experimented with, everything from cosmetics and semiconductors and carbon fibers, plastics, coffee cup insulation, you name it. There's all different kinds of ways that biochar could be used, including as a substitute for peat in potting soils. So what does it take to switch from just burning up your piles to managing them differently and saving the carbon? Well, so many of us, or so many farmers, have looked at this excess material that comes off their land as just waste. And sometimes it gets plowed back into the soil, but many times it gets burned. And so what we're doing here is we're just taking an existing practice, altering the way it's managed, and saving as much of the carbon as possible, and in the meantime, reducing the amount of smoke. So you have to plan ahead. You can't just pull your vines and 3 weeks later burn them. They really need to be about 20% less in moisture. So you could just buy a regular moisture meter. We use a digital one that reads the amount of moisture, and once it gets down to that an average of 20%, then it's ready to burn. So you need to also follow your local burning rules. This is really critical, especially out here, but probably in your area too. I don't have any idea what the regulations are there, but always make sure you do follow those burn rules. Out here, you're supposed to have dried them for a minimum of 60 days. That isn't always done. There's a minimum pile height and things like that. So just make sure you understand, and really critically, absolutely no treated wood, plastics, or other non-plant material. You just definitely don't want to have any of that in your biochar. I don't know about trellising back here. There have been some issues with older vineyards where the trellis has actually grown through the vines. We go ahead and burn them anyway with the trellising in it. It just takes a little bit longer to kind of rake that material out and manage it. So if there's a way to not have the trellising in it when it's burned, that's ideal. Some vineyards out here, especially the older vineyards, don't have that kind of trellising, but the newer vineyards do. So that can be an issue, but it's okay to burn it with the trellising, just not with the stakes. So again, that's something to consider. You need to make sure you have all the right equipment to do the burns. We use McLeod's often to rake out the material. I'll show you that a little bit later. We use a propane torch and a weed burner and a propane tank. We don't use any other accelerant. We try to minimize the amount of propane, and if it's good and dry, you don't have to use very much. So we're very cognizant of using as little fossil fuel as possible. And some people down in Southern California just use newspaper and light it with a match. So however you can minimize your use of accelerants, the better. You always need to make sure you have, when you're doing these piles the way we do them, you have heavy duty welding gloves, because we are going to be raking into the pile. Heavy duty boots, fire resistant clothing, all the stuff. Goggles are really important, and a hard hat, facial heat shield. So make sure that you have the right equipment when you're conducting these burns. So these are piles. Let's see. Not sure which. I can't remember which vineyard this was. I think it was Clos de Bois. So they assembled their piles. They used machinery to do it, but they were very, very careful not to scoop up a bunch of dirt with it. They shook out the roots as much as possible. You want to make sure that you have as little dirt as possible in these piles. And then they had covered them because they had there was some rain, and then they uncovered them, in dry weather to dry them back out. So I don't know what pile size you have in this area. This is a very common pile size. So once you've got your piles ready to go, we create sort of what we call a bird's nest. It's not a very good name, actually, but it's an area with lots of kindling at the top, so that you can get your fire started. This is, again, you light around the perimeter of the whole pile unless it's windy. And if it's windy, then it's really important to light the pile on the downwind side. And the reason for that is the same kind of sort of physics of lighting the pile from the top, is that back in this area here, I don't know if you can see my cursor, this is where the smoke is gonna start happening here. And if you light the pile on the upwind side or back here, it's just going to allow that smoke to escape. So by doing it on the downwind side, the smoke that's created back in here goes up through the flame front, and again, very cleanly incinerates it. And so it's a very simple technique. And put that as a kind of a critical part. So I'm just going to kind of show you quickly here. This was a burn, another burn that we did. Again, it was a little windy, so they lit the pile on the downwind side, and heat goes in all directions, so you don't have to worry about the pile burning back into the wind. It does so very, very easily and successfully. And actually, these piles, the top lit burn can burn much faster than the bottom burns, and it does help to have some wind as well. So this is about 30 minutes into the burn. This is about 1 hour into the burn. You can start to see some ashing that's happening. This is 2 hours into the burn. You can still see some of the morphology of the vines there, but it's really starting to get a nice ash on it. However, at a little bit longer into this burn, we start to put the fire out, and we actually rake it out. So in this case, we only had a little hose, but we don't recommend that. We really recommend having a water truck or a 500-gallon water trailer or something, and a 1-inch hose. It goes much, much faster. Anyway, so the workers, start raking out the carbon and putting it out as they work their way into the pile. And it doesn't take really a super long time, but this is what ends up in the end. So a very large amount of that carbon that was contained in the plant material was saved as biochar. There will be some torrified pieces, some pieces that weren't completely burned. That's why putting the fire out at a certain time, you sort of get used to knowing when to put it out, when you're actually starting to, when it's the right time, and you've burned most of it, or heated most of it to the point where it turns into char, but doesn't turn all to ash. And this is, so, we had a really nice pile of carbon here. Again, this particular winery did a great job of seasoning the material. They actually placed these burns right next to where they do their composting. So they just move the carbon directly into their compost pile, which is what we recommend, and then seasoned it over a period of time with the compost and then applied it after that. So here is a video. I'll try to see if it works, of lighting the Ring of Fire flame cap kilns. This was done up in the USAL forest, but this is easily done. We demoed this for the Napa RCD recently as well. Let me see if I can get this, if it'll play. Oh, well, it's not going to do it. So anyway, again, you put all this material into the actual flame cap kiln, and then you light it from the top. And in this case, you keep adding the material. And the flame cap kiln can actually process about 15 cubic yards per day. So you just keep adding and keep adding and keep adding. Whereas with the conservation burn, you do not add anything additionally. You let that burn down. It's also pretty important to have sort of similarly sized materials. And in this case, it was forest slash. And it burned very, very well and very quickly and easily because it was well aged. So this is just an example of what the kiln looks like as people were continuing to add material in. And then at the end, we cool everything down. The kiln, we undo it, and we actually open it up and rake out the char. The kilns make a higher quality biochar, and they can make a significant amount. So we have actually switched to this method. We have 5 kilns. They cost about $1,000 each, and they're a very, very efficient way to make biochar. However, there are many, many different ways that you can do this, depending on what you have on your farm. This is a Kontiki kiln. It was pioneered by in Europe, and so it has this kind of conical shape. And again, you can see it can make a big pile of char over time. This is the atom retort. This is the machine. We actually got a grant to operate this back in 2013, 2014. It's made by New England Biochar. You can look them up. And it's basically an oven here. And it started back over here with a little bit of propane and wood chips. And then it heats up the material in here. And the gases are fed back through here and then back into the system. So it's actually a very, very clean system. It doesn't create a huge amount of biochar, but it makes excellent biochar, and it's very efficient, very low emission. I think this unit cost us around $100,000, however. So you can see how those kilns are starting to look like a pretty good investment. So this is important too. As in that last sample I showed you, that vineyard manager created a special place on their farm where they did the actual burning. If you do the burning out in your field, which a lot of people do, it can actually damage the soil temporarily. This also allows your material to season away from your fields over time, so that you can just go back to working your fields without worrying about waiting for the material to season. If you're worried about disease, you might need to burn it sooner and just get rid of it as soon as you can, but wait as long as possible to do the burn. This does require some planning and some different ways of managing the piles. It does take a little bit more labor, but in the end, you get the biochar, and I think hopefully you've seen that how important and what a great material it is. So just a note about critters. Obviously, there are birds that nest in these piles, and we've had rabbits in them as well. So you want to kind of make sure that those critters aren't present, and you can do that usually by burning as soon after burn season starts as possible, rather than waiting over the winter and then burning in the spring. So just something to think about. We always like to make sure that our wildlife friends are taken care of as well. So what do you do with the char then? Once you have these piles, you do want to reduce the size. You get often really big chunks of char when you're using vines or other material. So if you can, you want to process it. You want to get it down to maybe a 1/4 inch minus is usually pretty good, because if you have big chunks, you're wasting a lot of that internal surface area that can be used. So get it down to a manageable size. You can do that by rolling over it with your truck or a tractor. There's actually pavement rollers you can rent, and you can take this material to a cement area somewhere, put it down and roll over it. So there's many different ways you can get it to that point. And then you want to blend it. You want to inoculate it. This test we did, actually, interestingly, on the Oasis Vineyard showed that biochar application alone worked okay in this situation, and actually created very good growth as well compared to the control. But as a general rule, we recommend that you blend the biochar with compost and then apply it as you would your normal compost. We highly recommend that you apply it in a new vineyard when you've pulled an old vineyard and are replanting, and put it actually down the vine row before planting. Blend it in with the compost and whatever other nutrients you want, and then plant your vines right over that. And that tends to be the most successful. That's what we did in the Oasis Vineyard. But you can also delve in biochar on the sides, or you can actually blend it with your ground cover. If you do that, we do a lot of that out here. I don't know if you use ground cover in the winter months, but that's another way you can do it, and actually just apply it down the center row. So again, here's a picture of the vineyard in Monterey that we did, and that biochar and compost was blended right in the vine row where the vineyard was planted. Go forward here. So there's also been a lot of interest in applying biochar to rangelands and increasing the soil organic matter, soil organic carbon portion of the soil. Many of our rangelands are severely degraded. So there has been some interest in that. We also did a not too successful field trial. We had some issues where the sheep got into it and messed things up. But we think there's a lot of promise in increasing soil organic matter and the soil carbon, which will increase plant growth, which if you have grazing animals will increase the amount of material they can eat. So again, there are some people that actually you can reduce biochar to powder form, and you could actually put it into your drip irrigation. There's some people that are doing that. And again, you can use your cover crop material. So again, there's as far as application rates, there's been a lot of variety there, anywhere from 1 to 20 tons per acre. You're not going to make enough biochar for a full-scale use in your vineyard by doing a conservation burn or even the kilns. So at some point, after you've maybe experimented a little bit with the material you can make from your kilns, and you find that it is working for you, then you'll have to look for a larger source to be able to apply larger amounts, which typically have been between 5 and 10 tons per acre. And that's between 10 and about 100 cubic yards. So it's a lot of material. One of the drawbacks of biochar up to this point is that it's been relatively scarce, and so it's been relatively expensive. About 5 years ago, they were getting about $300 a cubic yard. Now it's down to 100 and maybe even 80 in quantity, at least out here. So it's getting cheaper, and there's more and more biochar coming online in quantity. So I expect that it's going to get down to, be similar to compost in the not too distant future. So here's a few other ways that you can produce biochar in larger quantities. We had a forester out in our area purchase what's called a Tiger Cat carbonizer. Tiger Cat is a well-known forestry company, and it makes this large industrial scale machine that processes about 15 tons a day of material. It doesn't have to be chipped, and it produces biochar as well, between 10 and 15% of the material. So it's for very large applications, it works. It does cost about $500,000, so it's not something that you're necessarily going to buy for your farm, but there might be more and more of these coming online that you could rent, and maybe your organization could, group together and rent one and process that material and then split the biochar that comes out of it. Just here's another shot of it. It does require a water truck and an excavator or something to actually load the machine. There's a lot of cool features that you can do remotely, and it produces very, very good biochar as well, because it's designed exactly for this, to actually convert the material into biochar. How am I doing on time? I can't see a clock.
You've got about 5 to 10 minutes.
Okay, good. I think I'll get there.
I mean, until the Q&A.
Yeah, okay, great. So here's a couple of other systems that are sort of medium scale. Again, they're anywhere from $500,000 to $1 million plus. But these are systems. This Artie system here up above is actually out of Iowa. There are a bunch of Iowa State students that created this company about 10 years ago and have been refining the system. It's a pyrolysis system. It produces heat and biochar only. It's very clean. There's a modern emissions system that's connected to this, so it's very clean. We actually got a CAL FIRE grant recently to purchase one of these systems, and we're working with a tree care company that produces massive amounts of wood chips every week that get landfilled in the Bay Area. So we're going to be diverting those landfill chips into producing biochar, and this tree company has been using biochar in their tree care activities for about 5 years, and they're very excited to not only divert all these wood chips from the landfill, but also produce a material that they've already been using and recycling it back into their operations and their tree care facilities. There's a great project called the Stockholm Biochar Project, which if you're interested, you can look that up, but it's been a very successful project. In that case, they actually are using this PyReg unit down here to produce electricity. It produces waste heat. They use it to go back into their municipal landscaping activities, and been very successful doing that. So we're hopefully going to start this Artie system in about 2 months and actually start producing biochar. So we'll have it's a 2-year project. We'll have some updates that on the Sonoma Biochar Initiative website as we move along. And then there are also large-scale systems out there that produce electricity or waste heat that are used in boilers to boil water and then produce electricity. There's a lot of, in California, there's a bunch of these plants that are being reconditioned to produce more of a carbon product, and rather than re-injecting that carbon back into the system, they're diverting it, taking it out, and producing truckload quantities of biochar. Now, there's quite a lot of controversy about these biomass systems right now. There's a lot of environmentalists that are against these large-scale plants. for various reasons. We think that as a transition, until we have other methods and other ways of building up. Right now, solar, I think it provides about 3% or something like that of our U.S. power production, and wind I think they both are about 6% together. So we have a ways to go before we can rely on these very much cleaner systems. So if we can produce truckload quantities of biochar for a while until we have other methods that are cleaner. And the environmentalists, which I consider myself one, I'm a Sierra Club member, are not as upset about the smaller units. And the one on the left here is made by Phoenix Energy, and this is actually a 500 kilowatt plant. This one here on the right is a 30 megawatt plant. So a lot of it has to do with scale and how emission-free we can produce it. We can, produce the energy and also produce the biochar. So we're looking to that right now. But as a farmer, if you actually wanted to get enough biochar for your whole farm, this is where you would most likely have to purchase it. So this is my next to last slide. I just wanted to, reiterate that for so long we've looked at, a lot of material in our workflows as waste material. And I think that your organization is on the right track, looking for more sustainable ways to produce wine, and certainly reusing the excess material that's coming off of your properties instead of just burning it all to ash or chipping it, where all that CO2 will eventually, most of it will go back up into the atmosphere. If you can, turn that quote unquote waste material into something you can use back in your farm, all the better. There's a couple of good links here. There's a kiln project that I showed up in the USL forest. There's a good webinar that we did on that. You can go to that. We have about 25 presentations at the scalingbiochar.com website. We did last October, a lot of good information there. And here's the link to the Oasis field trial. It's at the SonomaBioCharInitiative.org website /resources. And you can look up that study there. So that is it. So I'm happy to take any questions. I will stop sharing my screen.
Thank you, Raymond. I do have some questions in the Q&A box, so I'll just go right in order and read them to you. First one is, could you make biochar from the pumice wineries produce?
Absolutely, yes. Yes, although it would be, that material is very different. You might be able to do a combination in these kilns of using a woody matter and then, adding in some of the pumice. But I think there's different ways to do that. In fact, this Arty machine might be able to handle that. But yes, there's interest out here for doing that as well. Although we've always sort of looked at, if you can compost the material, compost it, because it's filled with nutrients. You might as well go ahead and, put that into the compost and then blend your woody matter in with the compost and then use that back on your field. But the answer is yes, you can make biochar if you have the right machinery out of any biomass material.
Okay, great. Next question, what would the difference between pre-chipping the wood versus leaving trunks whole do?
Well, you can, in the kilns or the conservation burn, you don't use chips. So there isn't any difference in the end product per se. Necessarily, you'll get different sized material. But these units like the Arty machine and the, different machines, the Atom Retort, other ones, those take wood chips. And so you would want to chip it and then use that material. But the advantage of the kilns and the conservation burn is you don't have to prep the material in the same way. You don't have to use a chipper. In the kilns, you do have to have the material has to be 4 inches in diameter or less and 4 feet long or less. But that works pretty well with most of the vines. We do bring a chainsaw along with us and kind of saw up the areas to keep it below. With the conservation burn piles, you don't have to do any of that. You just burn that material as is. I don't know, did that answer your question? I hope.
Yeah, I think so. Another question from someone, I heard biochar has increased grape quality. Can you address this?
It depends on what you mean by quality. Again, in the tests that we did, the Oasis field trial, I encourage you to download that, read it. It increased the canopy, it increased the size of the grapes, the actual amount of grapes significantly, using the same amount of water, but it did not significantly increase the qualitative parts of the grape, which in our view is a good thing, because it didn't affect it adversely, even though you got more production. There's another study that was done in Europe by Hans-Peter Schmidt. It's a 4-year trial in Tuscany. You can look that one up as well. You can Google Hans-Peter Schmidt Tuscany Vineyard trial. That was a 4-year trial, and they had similar results where it was a dry farm. They increased the grape production, but there was not a significant increase or decrease in quality of the grapes. So I'm not familiar with any studies. There may be out there where it increases grape quality, unless you consider the grape quality production. And I don't think it's not across the board either. I think we're still kind of, looking at, as I mentioned before, there's no 2 biochars that are the same. There's a lot of different qualities depending on the type of feedstock that's used, the amount of the temperature that the biochar is produced at, how long the residence time in the process is, and then what type of soil it's used, and what type of what it's blended with, and there's a lot of different factors. So we're still kind of figuring that out at this point, but it definitely is best works best in degraded soils, and it should improve plant growth and maybe plant quality in your worst areas of your farm, as well as particularly in sandy soils, because in sandy soils, those nutrients and water, it tends to, soak through and not remain, whereas the biochar can hold it in a preserved state and sort of dole it out to the plants over time. So the Oasis field trial was a particularly sandy soil type, and it did work particularly well there.
Right. I guess you could say it's, like you said, it's a buffer, but it really depends on how you manage your vineyard. But it's certainly a tool to increase soil health and soil life.
Exactly. And we're just seeing more and more. There are thousands of peer-reviewed articles now in different aspects of biochar, and it's definitely gaining interest, actually mostly on the climate side right now, because of its ability to sequester carbon. And farmers are starting to get interested. Actually, Pacific Biochar sold the first carbon credits on the European carbon credit market. I think it was through Puro for $100 a ton, which the regulated market is around $15 a ton. So it's much more this on the voluntary market. So there's a lot of interest in that. And I think as we move forward, as more and more companies want to offset their greenhouse gases, I think biochar is going to become a real player in that. Again, it's not going to make anybody rich, but as an added amount, every little bit helps for the farmer, right? And if you're improving your soil, if you're using something that's already on your property, either on forestry or your vines that you normally would be getting rid of or chipping anyway, I might as well make biochar out of it, and then eventually there'll be an account, a protocol to account for that, and you can get some credit for that material as well as improving the soil health. So kind of a win-win-win.
One last follow-up question. If using pumice, would it be best to dry it out first?
Definitely. Yeah, definitely. And I don't know, I would experiment with that. The problem is if you're blending the pumice with woody matter, the pumice is just going to, it's just going to go to ash by the time the rest of the woody material is there. So you'd almost have to come up with a process specifically for the pumice that would make it, charred at the right temperature and keep it in a charred recalcitrant form rather than just burning it to ash. I think some people have done it. I'm not sure if I, do a little research and can find anything. I'll let Andy know about it, and then he can spread it out. Or you can just try to Google it. There may be some studies out there that I'm not aware
of. So a couple more. As panelists, Ishmael and I cannot type into the chat. We have to ask you directly. So for my question, I'm going to do some conservation burns around the farm here pretty soon from prunings. And I think I discussed this a little bit with you on the phone previously. I expect the yield to be much lower considering it's 1-year-old wood, but what we have is we cut out trunks after 2-3 years fairly regularly. We're kind of on an alternating program at this point. So there is some smaller, thinner trunks mixed in with the canes. Any tips on, and this kind of goes along with the slides that you showed about the ring of fire as well, just whether you're doing a kind of somewhat enclosed system or a conservation burn system. You had the slide there where it had the ash pile down. I'm just wondering about how exactly you determine the point at which you start applying water and raking it out. Or is there a way to test that? Can you probe it with something to see if there's a certain size chunk that it's breaking into, or how do you know?
That's a really good question. And it really, even after, 35 to 40 of these trainings, we're still kind of honing that. It's really an art, as much art as science. And what I found is I tend to want to do it too soon because I'm worried that, that it's going to burn to ash. But if I let it go, 20 minutes, half hour longer than I think it should, usually it will more efficiently char most of that material. You'll have very few uncharred pieces, and you won't lose an enormous amount. But just trial and error. That's really, we haven't done a probe or anything like that. It's just sort of a visual cue. But probably by your 4th or 5th pile, you'll have a better idea as to how much material. Now you can still rake out all that uncharred, torrefied material and put it onto the next pile, and you can still utilize all that material. But you definitely want to rake everything out until the unburned pieces, and just stick with the char. But again, you'll have to experiment with it and let me know how it goes.
Okay. And Ishmael is our MSU researcher here, our extension person, and he has a couple questions too. Ishmael, go ahead.
Hi, thank you for the very comprehensive and very insightful presentation. My name is Ismail Nasrullahi. I'm viticulture extension educator in Michigan State University. So I have a few questions. Most of them is related to our soil type. We have very sandy and beautiful soil here in Northwest Michigan, but however, we have some problem with them, with our soil type too. We have very high oxidation of the organic matter and leaching the mobile element of the soil, and also soil erosion. What's the impact of biochar in solving those problems? Already you mentioned about leaching, preventing, keeping the element in the soil, but could you please explain a little bit more about this for preserving the element in the soil, please? Thank you.
Sure. Well, again, because of the physical characteristics of the char, it has very high adsorptive and absorptive qualities. And so, nutrients will stick to it and also be absorbed by it. It reduces, and so that the biochar will act as a storage architecture, essentially, that will help, prevent leaching. And again, you'd have to experiment with the actual amount of that, but it's very unique adsorptive and absorptive qualities that, when put in the right amounts in the soil, will definitely, especially if you have sandy soil, I think you'll have a lot of success with getting rid of some of those issues that you have. I'm not sure about some of the other issues. I'm not a scientist. If you had specific questions about this, you might want to contact Johannes Raymond at Cornell. And actually, if you go to our scalingbiochar.com website, and he had a very good presentation on this, and there's a couple of others I think that did as well. So go to that website and they'll explain a lot better than I can the scientific reasons of why biochar does what it does.
Thank you. And my last question is, what's the best time to apply biochar? In fall or early in growing season? What's your suggestion?
Well, again, it depends on the very best time to apply it is when you're doing a new vineyard, a new planting, or you've pulled out an old vineyard and are replanting. Again, adding it to where the vine row is going to go, blended with compost. If you're going to add it to an existing vineyard, and I don't know if you do delving out there, but there's a special delving plow that goes along kind of the sides of the vines. I would do that probably in the fall. But again, I would use blended biochar and compost together, or whenever you apply your compost. I don't know whether, do you guys apply a lot of compost out there, or and if so, when do you apply that? Do you apply that in the fall?
Yes, organic matter, the level of organic matter is very low here, so we try to keep it around 2-3%. We have to add compost, so biochar will be another solution. We can blend those, compost with biochar. It's a good idea.
Yeah, we've found, there are studies that show that it's best to add the compost to the beginning of the composting process. So you can get compost and biochar and blend it and then use it, but it's better and its efficacy is higher if you actually add the biochar to the compost during the composting process. And when the compost is done, the biochar will be sufficiently inoculated, and you would add both together. In general, between maybe 10 to 20% biochar to 80% compost is a good number. There are some studies that shown as little as 5% can also be effective. We're still kind of figuring that out from a cost efficiency standpoint, and it probably depends a lot on the soil type as well. But I would do anywhere from 10 to 20% biochar to 15 to 20% or 80% compost, something like that, 85%.
Okay, thank you so much.
Mm-hmm.
Yes, thank you, Raymond. Excellent talk, very informative. Excellent pictures, and I'm going to direct anyone with further questions You can look on the Sonoma Biochar Initiative website. It's very helpful, and there's videos on there and other links to other pages from there as well. Or you can email myself or Ishmael, and we can pass questions along as needed. So thank you very much, Raymond.
Great. Thank you so much for inviting me. I really appreciate it.
Yeah, have a good rest of the Friday.
Okay, take care.